So basically, what I'm going to share with you today is some, potentially new, exciting research we doing now in University of Adelaide, and in a non-scientific way. So this is, in a way, joint research between University of Adelaide and colleagues at Indian Institute of Science and University of Gothenburg, and basically, the idea is there, to use glauconites, which is a rare mineral in sediments, to date that. So, I'm not a geochronologist, so as you can see, the title said telling the time. So it's basically talking about the geochronology. But my background is a low temperatures isotope geochemist, and when I moved to Australia a few years ago, I realized, the bread and butter of geochemistry there is geochronology. So in a way, to be taken a bit more seriously there, I realized I have to do a bit of geochronology there. And by serendipity of events, we acquired one instrument, which is called a collision cell mass spectrometer, which allows us to date the minerals in non-traditional way. So I'm just going to illustrate it a little bit. So normally, if you want to do the rubidium-strontium dating, can I get a first click on the slide? Yeah, so that's the illustration here. So as a geochemist, traditional way, you want to do rubidium-strontium dating, you separate rubidium, which is your green apple, from strontium, which is your red apple, but you have to do it in the clean lab. So it doesn't allow you to analyze samples with laser. So what this new instrument allows you to actually separate these two apples or two isotopes in the instrument. And if you can do that, then you can basically separate these elements online, and you can then date individual minerals with laser. So that's shown there, that you can, from a single glauconite grain, which is about 0.5 millimeter big, you can basically put few spots through that mineral. Can I get the next slide? And
you have a clicker already.
Yeah. And what you get is basically the age. So by this means, you can get age of the mineral, which is 1.64 billion years. So in a way, this is a new way how you can start dating minerals with laser. And how the system works, just last minute, is we have a collision cell, and basically rubidium you have the cell filled with oxygen, so this will be oxygen, and rubidium will fly through that cell, and you can measure it at rubidium-87, but strontium is very friendly with the oxygen, so it will combine, and you measure these as strontium with different mass. So this way, we can separate these two isotopes and get the age what we need. So I'm sure we'll be seeing more of this, research in the future in Goldschmidt, and I think I'll finish that. Thank you.
Thank you so much.